Hello everyone, welcome to Analytics with Asmi. This video is Power BI Interview Question for Beginners Part 2. I have created a separate playlist for interview preparation. Link is given in the description box. This interview series will definitely help you to ace your Power BI and data analyst interviews. So before moving ahead, make sure to subscribe to my channel for more such videos. Now let's start. These are the topics which we are going to cover in this video. So the question will be from general topic, Power Query Editor, Power Pivot and Power BI Service. So the first question will be from a Power Query Editor. This question is asked in our channel by one of our followers. So the question is, tell me the difference between enable load and include data refresh. So the sample answer should be, in Power BI, enable load and include in a report refresh are both options related to a data refresh. Enable load, this option is available when you are connecting to a data sources and configuring a data loading settings. When you select the enable load for a particular data source or a table, it means that you want to include that data in your Power BI data set when it is refreshed. This option determines whether the data from that source or a table will be loaded into a memory and available for querying and visualization within a Power BI. Whereas include in a report refresh option is available when you have a multiple data set within your Power BI file, also known as a Power BI desktop file. Each data set may be based on different data sources or queries. When you select include in a report refresh for a specific data set, it means that you want that data set to be refreshed along with all the other data set when the report is refreshed. This ensures that the data in all the dataset remains up to date when users interact with the report. So in simple terms, enable load determines whether the data from a specific source or a table is included in a dataset, whereas include data refresh determines whether a specific dataset is refreshed along with the rest of the other report dataset when report is refreshed. Both the options are important for managing the data refresh process in a Power BI. Hope you understood it. Question number 2 is on data modeling. The question is, why star schema is a top-down model and a Snowflake is a bottom-up model? Please explain. Now, both is used in the context of designing the data warehousing and data modeling. In star schema, data is organized into a central fact table surrounded by multiple dimension tables. Fact table contains a quantitative data such as sales figure or quantity and typically has a foreign key that link to a various dimension tables. Dimension tables contain a descriptive attributes related to the data in a fact table such as product names, customer details or a geography. It is often considered a top-down approach because it starts with a central fact table. Okay, this is in center. You can see there is a fact table representing the core of a data, and the dimensions are added around it. That is why structure of a star schema resemble a star with a fact table at the center and dimension tables radiating outwards like a pointing as a stars. The star schema is more denormalized and resembles a star shape. Guys, if you don't know how to create this fact table and dimension table from a flat file, I have already created one video on this. Link is given in a description box. You can watch it. Now let's see why Snowflake is a bottom model. Okay. Snowflake schema is an extension of a star schema where dimension tables are normalized, meaning they are broken down into a further subdimension or levels. Here you can see in the diagram, here in the center fact table is there. Then from this fact table we are getting this dimension table, and this dimension table is further broken down into subdimension tables. Then we can call it as a Snowflake schema. In Snowflake schema, each dimension table may have one or more related tables. Here you can see for this dimension table we have two related tables. Okay. creating a branching structure resembling a snowflake. Unlike the star schema, which keeps dimension table denormalized, the snowflake schema breaks down dimension table into smaller parts. Hence, the term is called as a snowflake. Now, it often considered as a bottom-up approach because it starts with a highly normalized structure and builds up by adding additional levels of details. So, it is called as a bottom-up model. Hope you got it. Now, if you are able to answer the previous question which are related to snowflake and a star schema, and if you mention the terms like normalization and denormalization, then interviewer might ask you a further question like what is normalization and denormalization. So, the answer is normalization is a process of organizing the attributes and tables of a relational database to minimize the redundancy and dependency. The primary goal of normalization are to eliminate the data redundancy, means data duplication, reduce the data anomalies such as update anomalies, delete anomalies, and ensure the data integrity. It typically involves breaking down a larger table into smaller related tables and defining a relationship between them through keys such as primary key and foreign key. Means normalization usually involves splitting a tables into a smaller one to achieve a specific form of normalization, often represented as a normal forms like 1F, 2F and 3F. Here in the picture you can see that if you have this large table where we have 7 columns, and now this large table is broken down into these smaller tables. Here we can see that this larger table broken down into these 3 tables. Table 1 is a sector table, table 2 is a manager table, and third table is a employee table. Here sector table contains information specific to the sector, whereas manager table contains information specific to a manager, and employee table establish the relationship between the manager and the sector with respective IDs. Here you can see we have 2 IDs. So these IDs are here foreign keys. Okay. And here it is a primary key. So this normalization helps eliminate data redundancy, data duplicacy, and ensures efficient data management. So this is called as normalization. Now denormalization is opposite to a normalization. Here you have to duplicate your data. It is a process of intentionally adding the redundancy, means duplication, to a database design to improve a query performance or simplify a data retrieval by combining the tables. Here we are combining the tables to a larger table. Okay, it is opposite to a normalization. It involves combining tables and duplicating the data, thereby reducing the need for joins and aggregation during the queries. As we are joining the table, here we don't need a use of a join and aggregation during the queries. The purpose of this denormalization is to improve the query performance and simplify a complex queries. As we are converting it to a larger table, we will get a fast query performance here. It will improve. Okay, it reduces the need for joins between the multiple tables, making queries little faster. But here we have one disadvantage, which results in an increased storage space and potential data inconsistency if updates are not managed carefully. Now, continuing with the earlier example, denormalized version could involve merging the sector and a manager table into a single table. Here, sector and manager information are combined into one large table, make it easier to retrieve data about a sector and a manager with a single query. So, in short, normalization aims to reduce the data redundancy and maintain the data integrity by breaking down into a smaller tables, logically connected tables, while denormalization introduces redundancy to improve a query performance and simplify a complex queries. The choice between the normalization and denormalization depends on a specific database requirement, performance, storage, and data integrity. Guys, we know that we always prefer the star schema for data modeling in Power BI. So this is very famous frequently asked interview question, which is why star schema is used for query optimization over the Snowflake schema in a Power BI. So the answer should be like this. First point is its simplicity and the performance. Star schema tends to be a simpler and more straightforward than Snowflake schema. Its structure is optimized for querying as it consists of central fact table and surrounded by the dimension table. This simplicity typically leads to a query performance. This is the first point. Second point is reduced joins. In star schema, there are fewer joins required compared to the Snowflake schema, as we have already seen in denormalization. With fewer joins, query execution time is often faster. Snowflakes, on the other hand, involves more complex joins between multiple dimension tables, leading to a slower query performance. Third point is denormalization. Star schema often involves denormalization, means they contain all relevant attributes for a particular dimension without further normalization, means it is not divided into subdimension or levels. There is a redundancy in a data which helps in query performance. Fourth and the last point is simplified data modeling. Power BI is optimized for a star schema data modeling. Its features such as relationship, hierarchy, DAX calculation work more efficiently with star schema compared to Snowflake. In Snowflake schema, it may require more effort to manage the relationship and optimize the performance compared to the star schema. So these are all the reasons why we are prefer star schema data modeling in Power BI and why star schema is used for query optimization over the Snowflake schema. Last question is on Power BI service. The question is, what could be the reason if data refresh fails in a Power BI service? So there could be many reasons. I have mentioned here the 6 reasons. So you can answer like this. First is data source connectivity issues. This could occur if the data source is temporarily unavailable, experiencing a network issues or undergoing maintenance. It might also happen due to a DNS configuration problems or changes in a network policies that prevent Power BI service from connecting to the data source. Second reason is insufficient permission to access a data source. If the user account used for a data refresh lacks necessary permission to access the data sources, the refresh will fail. This could be due to the changes in the permission settings, such as revoking access for a service account used by Power BI. Third reason, changes in the data source credentials. If the credential used to access the data source have changed, the existing connection may become invalid, leading to a refresh failure. This can happen if the passwords are updated, access token expire, or there are changes in authentication methods. Fourth is changes in the data source schema. If the structure or schema of underlying data source has been modified, such as renaming of a column, changing the data types, or altering a data table relationships, the refresh process may fail. Power BI relies on the schema of a data source to map a field correctly. So any changes to the schema could disrupt the refresh process. Fifth is large volume of a data causing timeout. If the data being refreshed is extremely large, the refresh operation might exceed predefined timeout limits, leading to a refresh failure. And the last point is resource constraint on a Power BI service. If the Power BI service is experiencing a resource constraint such as a high CPU or memory usage, it may struggle to execute a data refresh operation successfully. This could occur during a peak usage time of if the underlying infrastructure supporting Power BI service is under strain. When troubleshooting a data refresh failures in the Power BI service, it is essential to investigate each of these potential issues to identify the root cause and take necessary actions. So this is all about this video. We have covered 5 questions in this video. We are going to cover more such questions in our upcoming videos. So stay tuned for more such videos. Thank you for watching.